Cool, okay. I'll just get started then. These slides are going to be slightly dark, I'm afraid. I'm not entirely sure why, but do shout if you can't see things. I can see them. I can tell you all about them. I'm Tim Perry, Pim Terry on Twitter, and I want to talk about build processes, about how they can go badly, and about how we can do them better. I work for a company called Software, which is quite useful here for context. So we build software for everybody else. We do bespoke development for other companies, and we've got offices in London and here in Bristol. But this means we end up seeing a lot of different teams build processes. We go into other companies and we help them build things, we build products for them, we join in their teams and help them build their existing products. So we get a lot of perspective of different kind of problems that you can see here. Things that work well and things that don't work so well. And this is what I'm really looking at here, trying to draw some useful information from various things, some of which have failed, and some of which have had problems for customers. So I should note that we are always hiring, so do come talk to me later if you're interested in that, and obviously we're available for hire. What I really want to talk about though is builds here. And when I'm talking about builds, what I'm specifically talking about is the tools and processes you use to actually take code individual developers write, bring it together as a team, make sure it works, and deliver it to customers. Delivering to customers is that we're actually doing something useful. This is the pipeline that takes what you do and makes it useful. I'm talking both about automated and manual steps here. Everything involved in putting stuff together, and getting it out, putting it into the hands of your customers, be that as a website, a mobile app, whatever. Why do we care about this? Fundamentally, this is the pipeline where you add value, where you do something useful. This is the tool you use that turns development from being a fun toy to changing the world and whatever. From making money, growing your business, making people really happy, whatever. Doing something useful and important. This is a very important process and it's very easy to do wrong. We see customers who turn up who are fighting their build processes, where their tools are an obstacle to getting something done. They're a problem that they fight, where they've set up processes that are there just to minimize risk without helping them actually succeed in any way. Or where they've gone the other way and they've set up loads and loads of exciting shiny tools that are really, really fun to play with, but not good at actually getting anything useful done. If we can improve these, if we can do better, we can build better software, and we can do so faster, and enjoy ourselves more on the way, hopefully. So, how do we make this better? I think one major point before I dig into this too much is this is gardening, not architecture. Software development generally is gardening, not architecture. You're not trying to build a beautiful ivory tower that is wonderful and people will talk about for generations. You're trying to prune things. You're trying to organically grow a system, look at it, see what the problems are, see where the weeds are, clean things up as you go. So we don't want to focus here on arbitrary perfection. We want to focus on improving things where we have clear problems, clear goals we're going to make better, and we're going to do concrete things to improve those. So for the rest of this talk, I want to go through a few specific bits of developer pain, a few build smells, if you were, things that suggest that something has gone horribly wrong, and how we can clean up after those, how we can kind of weed this and improve the system. We'll start with merging. As soon as you've got a bunch of developers making some changes and trying to combine the code, you start getting merge conflicts. We see teams where this becomes crippling, where you expect really that every week somebody is going to spend a day resolving merge conflicts, which is expensive, right? You're wasting a whole bunch of time at that point. And you see teams where this gets even worse, where as a matter of practice, you intentionally set up your project so that everybody opens a branch at the start of the 2-week sprint, starts working on their huge story, and everybody tries to merge it back in on the Thursday and release it on the Friday. And nobody enjoys Thursdays, and it's this huge problem and very uncomfortable, very painful. This is a smell. If this is happening, something is bad. You don't have to do this, and you can do better. This doesn't just waste time. Once you're in this situation, you can't refactor, for example. You can't make structural changes to your code, because as soon as you do, everybody else's changes fall apart. And you're in a position where the tools you're using to deliver good code are adding pressure against you delivering good code. So, how can we do this better? Critically, most of these conflicts are avoidable. This is going to be slightly contentious. I think there's 3 interesting classes of conflict here. So you've got sort of purely syntactic conflicts, where I and somebody else have made a change and they happen to be on the same line, so version control feels that there is a conflict, but they are totally independent changes. If two people have added a new field to a class, and they both happen to have done it in the same place, but they're separate independent fields, then these are totally independent changes. You could do them in sequence, and you would never notice there was a conflict. And that's key and kind of very interesting here. We also get more basic semantic conflicts, where you've got two areas of your code, you've made two changes, and they interact in some way that means they don't work together. But you don't necessarily have syntactic conflicts along the way. This is where it starts to get more dangerous. So, for example, you might change the return type of a method, and somebody else might add some new code that calls that method. As long as you've only made small changes here, actually resolving this is going to be fairly easy once you realise it's a problem. Perhaps you had an object and now you return a list of objects, and you just need to take it and grab the first or map over them or whatever. Fundamentally though, this isn't a core structural issue. You're not trying to do two things that are really in conflict. You just need to be aware of what the other person is doing to make your change work. And then finally, you do get actual fundamental conflicts. And this is where this doesn't quite work out. But these are fairly rare. I'm talking about conflicts here, like fundamentally mutually exclusive things. If I want to delete something because I need to redesign and restructure something, and you want to add a bunch of new code that uses it, we need to actually have a conversation and work out a new design that's going to work for both of us. These are relatively rare. Most of the conflicts you're coming up with are two people doing things which could be done in sequence relatively easily. If the other developer had made their complete change and pushed it before you, in many cases, you wouldn't even notice there was a conflict. If they changed the return type, when you added some code that just used that, you would just be like, well, this is the return type, this is how I use it, done. And thus, if we can share this earlier, if we can push this code and share the information at an earlier point in smaller parts, we can get rid of an enormous number of these conflicts. Fundamentally, these happen because we're isolating our code from one another. You're doing that as an explicit choice. When you put stuff on a branch and don't merge it to master, where you keep things local and you don't push it, you are keeping your changes secret from the rest of the team. You're isolating your changes. In almost every case, development is going to work out better if you don't do that. The other person is going to make their changes more usefully. They're going to take yours into account as they do so, if they know about them. And if you don't share them, they're not going to know about them. So isolation, in a lot of cases, causes these problems and is a bad thing. But we do it a lot. There's a huge temptation to keep stuff on branches, to keep making my changes until I've got a whole thing that's ready to go and ship it. But that has a cost, and the bigger this gets, the worse that becomes. This rapidly, exponentially grows in damage. If I keep something locally for a day, maybe I get some small conflicts. If I keep it for a week, 2 weeks, a month, when I try and merge this branch in, it's not only got loads of my changes, it's got loads of changes from everybody else involved. You get into situations where you really just can't merge this. Give up, work out what you tried to do, and just redo it again on master. This is very, very painful, so we really want to try and avoid isolation. And as I say, sharing your code earlier is the solution to this. I would strongly encourage trying to move to a situation where you share your code at the earliest point you possibly can, which is a point where you can push it and it doesn't break anything for anybody else. As soon as you've got some code that other people could have in their code base, and their code base would still work, the test would still pass, it would still be functionally working, do so. As I say, this is going to be a little bit contentious. This is very useful. We found this concretely working and saving enormous amounts of time on projects time and time and time again. Projects where it is very easy to branch all the time and you expect to have these conflicts, we see projects that you get a day of merging every week for somebody, and that simply disappears overnight and becomes a day every couple of months, every 6 months, whatever, when you get these fundamental conflicts, and everything else just disappears. This is easier said than done, but we can dig into some concrete bits. So, tests, for example. If you've written say you've picked up the code base, you want to start a story, you can do some nice DDE things. Say you want to refactor a bit of your code, so you write a passing test for it, it's not tested for whatever reason, and then you start refactoring. Once you've written the passing test, just commit it and push it, share it with everybody else. The code still works at that point, the test is ready to go, it's not going to break anything for anybody else, but by pushing that, you ensure that test is never going to conflict. Once it's pushed, if anybody else refactors the testing code, they'll refactor your test with it. If anybody changes how the mocks work, they change how any of the classes involved work, your test for free just works. And if you don't do that, you start building up tests on a branch, and then you find out you've got this problem a week later, everything gets way worse, and you have this huge issue that you have to kind of deal with. You have to rewrite a bunch of your tests and refactor all this thing, and you can just get rid of that for free. If you've got passing tests, you can just push them. Even if you've got failing tests, you can mark them as ignored and push them, and you don't get the same benefits of ensuring the test continues to pass, but you do get the benefits of any kind of compilation still working, any automated refactorings automatically coming through that. This kind of good behavior stuff that other developers are going to be doing as they refactor just comes in and helps for your code as well, because you're all working on the same shared code base rather than isolating yourself from one another. And similarly, we can do this in models. If you add a new field, a new method to some of your models or business logic, you can just commit that and push that and share that with everybody else. It doesn't functionally change or break the application, particularly if you've got some nice tests for it. And it does ensure that code is shared earlier and just gets rid of conflicts. Really, you can do this for almost everything. There are obviously caveats to this, but by and large, if you try and work in lots of small chunks, incrementally committing and pushing things, you avoid these conflicts, and you also get into a nicer way of working. It's easier to manage and organise the kind of changes you make if you focus on, right, I'm going to build a bunch of tests for this. Cool, I've built them, they work. I'm going to refactor in a sec, but now, commit, push, done. Repeat. Lots of small, standalone changes. In cases where this doesn't work, you can start using things like feature flags, which people may be aware of, that work really well to solve the other issues here. If, for example, I want to redesign the user page on my web application, that's going to be very difficult to do in a single commit that I push, because it's going to be a large task. There's going to be a lot going on. To do that, you can branch in code rather than actually isolating and branching in your version control. So you add some new configuration property, new user page, old user page, and you include both implementations. And if it's set, you show the new user page, and if it's not, you stick with the old user page, and you default it to off. So for everybody else, nothing changes. For you, you can start building and using your new functionality, and for everybody, you're working on the same code base. You're sharing that code earlier. Changes are easier. Conflicts just disappear because the changes are already there and easy and ready to go. Feature flags you have to use with some caution. This can become spaghetti if you're not careful, particularly if you're not careful about cleaning up after yourself once the feature flag is unnecessary. But actually, if you do this well, some major companies take this quite a long way, and it becomes a feature in itself. People like Lanyard, GitHub, Twilio use this to manage kind of alpha and beta testing. You can turn on features for certain users, you can do A/B testing, you can do progressive rollouts of new features. It gives you more control over actual functionality and allows you to isolate functionality without actually isolating the code within it, sharing code earlier. All of this is a bit difficult because we love branching. Branching is very nice, everybody's very excited by having loads of crazy branches in a complicated and confusing tree. And things like Git and Mercurial and so on have made this much better, and they are very good at branching, and it is a useful and powerful tool, but it is not the right tool all the time. We tend to just use it by default. This is an exciting, magical feature. Let's just branch everything. Cool, I've started a new story, I open a branch, I commit on it for a few days. Use branches because you actually have a reason to use branches. There is a cost to the isolation in it. Have some concrete benefit you're going to get back out of it. If you want to track released code on branches so that you can manage hotfixes effectively, that's great, that's perfectly reasonable. If you're building some experimental code that you're not expecting to go back into master, it's likely to be better to put it on a branch. If you're running open source projects and you need to have complex separation, you can't let people just commit. Branches are a nice way of managing that kind of pull request flow. But doing it by default on every single change has a big cost and is usually not necessary. So, that's really the first smile I want to get at here. If you're seeing these painful merges, if you're burning time fighting these, that's not necessary, you can do better. If you focus instead on smaller merges done more frequently, you can make them easier. You can get rid of a huge class of problems here. Let's move on. Okay, so we've got a bunch of code merged and we want to actually push it through our build system. This works well if it's very easy to push and you're very happy to be continually sharing stuff, but it's very easy to be on a team where pushing is scary. Where when you push, you don't know what's going to happen. Who here has ever heard somebody say this? It's very very painful. It's not a good sign. This is a bad thing. Something is wrong here. This smells. It suggests that you have no way on your local machine of having any idea what your build is going to do. That's clearly a bad thing. At the very least, this breaks the feedback loop. Right? I want to be able to very quickly write a bunch of code and know if it works. And I can't do that locally. I have to push and then wait. That's a problem. It would be nice to know definitively, locally, as I write things, whether they work. That would help me write code quicker and better. Similarly, this kind of thing, the build fails, run it again. Oh, it's failed. Run it again. At this point, you just lose faith completely. You no longer... so previously, we didn't trust some code that we had locally. Here, we've got some code, we've pushed it and we've built it. And we still don't know what the result is going to be when we build it. All of this really comes down to confidence. Powering an enormous amount of this stuff, an enormous amount of good development practices, the merging stuff I've been talking about, all of this kind of thing comes down to confidence. You need to be able to write some changes and know if they work and they're safe to share and they're safe to deliver, because that allows you to stop worrying about that and focus on building things that work and very quickly changing them when they don't work, having that information quickly. We want to be in a state where we can be confident about the changes we're making, about delivering these changes quickly. So, I think there's 4 main things that let you drive this. We want accuracy in our build, and we want thoroughness. And then we want this build to be quick and simple to use. So, accuracy. You've got a bunch of build steps, and I'm talking not just here about automated testing necessarily, but really anything that could tell you your code is broken. If you've got linting steps, this kind of thing, JS, lint, Rubicop, whatever. If you've got compile steps, all of this kind of thing. You want it to be accurate. If the code works, the build should pass. This needs to happen consistently, with no exceptions really. As soon as you start allowing this to slip, things go quite horribly wrong. The PHP team are probably my favourite example of this. They accidentally released in 2011 a version of PHP which catastrophically broke security for everybody, which is funny in itself. But also, they had unit tests that caught the problem, perfectly caught the problem. And they'd had these and they'd made this change quite a few days before release. And the person who made the change didn't look at unit tests and didn't care, and the person who shipped it up and bundled it into a release for millions of applications didn't care, because their tests failed all the time. Nobody trusted the tests, nobody really looked at them, nobody paid any attention, and it caused a massive security problem. And we see this happening in customers again and again. Once your tests stop being accurate, once you've got a few failures, you stop worrying about the failures and you rerun it and you don't really care and it's failed, but it's always failed. And then the list of failures grows because you don't really care about it, and very soon you essentially don't have tests. There's a few things you can do about this. I think these are probably the most impactful solutions we've seen. Trying to limit any kind of dependencies in your build steps. So unit tests particularly, it's very tempting to hook them into all sorts of other stuff, but really trying to isolate your unit tests from any external dependencies is a huge amount of value. And even for integration and system level testing, trying to ensure that they don't depend on a well-configured Tomcat instance already existing, for example, and instead they set up their own server and they manage that in some way. Trying to ensure that they can set up and manage their own identical environments and they don't depend on other dependencies makes it easier to have CI servers that consistently work and also to accurately get results locally. And having zero tolerance for failure here really is absolutely key to avoid these kind of problems. Once you have a test that starts failing, you need to disproportionately chase it down and fix it, or get rid of it. Having tests that randomly fail totally undermines your testing process and gets worse very quickly. It is better to not have the test, perhaps build some slightly less effective but passing working tests, than it is to have tests which fail half the time. Thoroughness. If you have code that works, if the build passes, the code actually works. The opposite here of accuracy, not the opposite, the flip side. So we need to be able to be confident once we've pushed something that if the build passes, it's genuinely a good thing. We have to have tests that give us accurate, real answers about what's going on in the code. Because if you don't, pushing becomes very scary. If I'm trying to share code with the rest of the team, there's a real chance that by doing so, without me realising, I'm going to break the code on everybody else's machines, or even worse, release something broken into production, then I'm going to avoid pushing. And pushing is a good thing. Pushing is sharing code. Pushing is moving us closer to release, where we actually get something useful done. And any pressure from your tools that is stopping you pushing is making your team worse. So, coverage. People dislike coverage with good reason in places. It is easy to focus on arbitrary targets for coverage. It's not necessarily a good idea. It is nonetheless useful information. The high-level message you get from coverage stats is important and valuable. The different areas of your code which are more or less covered is an important thing to know, and some tools make this even better. So things like ncrunch for C# and Wallaby for JavaScript will put coverage at the side of your IDE, line by line. You can see what bits are covered, and as you're writing tests, you can see, I'm writing something that isn't tested. Wait, this clearly should be tested. And you get this loop where it's very easy to spot these issues and quickly start testing them and improving them. This helps you improve your code and be thorough. Try to cover every risk somewhere. Some things are very difficult to unit test. That's kind of fine. Chasing down making some convoluted and very painful to maintain unit tests is not necessarily worthwhile, but making sure it gets tested somewhere definitely is. If you have to move it up a level, that's fine, but ensure for any given problem you have, you do have some test at some level. Don't assume this is difficult to unit test, therefore we won't test it at all, which we definitely see and is definitely a real problem. And finally, test what actually might fail. You get the flip side of this where people test too much, and they test every single case at the unit level and the integration level, and then running the entire system. And that is very thorough, but it will also rapidly make your tests very expensive to maintain and make it difficult to be thorough generally. It'll become a hassle, you'll waste time on testing, and you won't end up testing what actually matters. Test something when you have a clear idea of what mistake you might make that would actually make this fail. If you've got a getter, having a test that checks it, returns the value, is not useful. The only way that is ever going to fail, really, is if you intentionally make a change to it. All it's ever doing is adding a cost rather than any benefit. And you can bring that test up to a higher level, move it to some code that uses all the getters, where it genuinely might fail, where there's a bit more complexity. And there's a balance to this, but trying to focus on tests that you genuinely think could catch a problem, rather than tests where there is no way this is ever going to fail, will make it easier to be thorough and effective. Speed. The number one name of the game here for confidence is getting quick feedback when stuff fails. And I'm talking here both about success and failure. It's easy to get into a position where you push something, CI sits and twirls for 4 hours, and then tells you that all the tests failed. And that would have been really useful information 4 hours ago. This is very painful. You waste a bunch of time, and you get this context switching. You have to go back to where you were. It breaks you out of your flow. Once it starts happening, you start worrying about it, and after you push, you sit and you watch the build surfer, and you carefully check the things, and you're wasting time, and you're distracting yourself, and you're not feeling confident about being able to push and build things. We're going to chase quick feedback here. Anything you can do to get earlier information about whether your code is passing, whether your code is failing, will make you more confident and will make you develop stuff better. Unit tests particularly are a good case for this, so you want to get this really to the stage where it's kind of watchable. I can run the unit tests, and I'm not going to get bored just looking at them. I run them and I go, oh yeah, cool, looks like it's passing, yeah, great, done, continue. If you don't do that, I'm not going to run them. As Joe was saying, people are very lazy, it's a lot of effort, I don't want to sit and run a thing and then remember to go back and check it, and so I just won't do it as much. You want to build tools that encourage people to do the right thing, that guide you in the right direction, and make it easier to do this kind of stuff well. And smoke tests are an interesting case here once we get out of unit tests. It is difficult to get any kind of serious integration or larger scale tests to run quickly enough to do that, but you can build smoke tests to do so. So we've got a huge integration suite of tests. If we mark, say, 5 or 10 of them as being sort of key indicators of the overall thing, and most test frameworks will have some kind of tagging, categorization framework that lets you do this, then locally, if I want some pretty good idea of what my build is going to do, I can just run the smoke tests, and it will run 10 integration tests instead of 200, and straight out of the box, I can get a good idea that most of the pages in my application still work. Everything is fine, this refactoring is probably okay. And this works both locally to more quickly get confidence before I push stuff, but also remotely. If you put this on CI and you have a step that runs the smoke tests and a step that runs all the tests, If CI is going to fail, the smoke test will clearly fail, and we'll tell you sooner. We get quicker feedback. Finally, try to keep this simple. Again, people are very lazy. If you can put your build process into a state where it is easy to automatically check that what you're pushing is good, then people will do so. Get it into a state where you have very little, hopefully zero, setup. I can check out the code, I run a command, and it doesn't need dependency installs, it does, and runs tests, and everything's great. If you can get this down to one click, people will actually click it. If there's 20 different steps I need to do to run a build, I won't. I will make a good guess at what the 4 ones that actually matter are, and I will be wrong, and then I'll end up pushing things that break, and then I won't trust the build, and nobody will trust the build, and we waste time, and we lose our flow, and we stop getting useful work done. And finally, try to focus on making this actually debuggable locally. If you have really great system tests, but it's impossible to run one of them at a time, then I have to run, then if one of them fails, I have to run the whole suite, and it's a hassle. So I avoid doing that, and the easy way of avoiding doing that is seeing a system test fail, checking it out locally, going, I totally know what the problem is, I'll just fix this, yeah, that'll definitely work, I'll just commit it and push it, and then it fails again, and so on and so on. If we can get it into a state where it's very easy to locally reproduce what's happening in the CI server and check and quickly get this feedback loop of fixing these tests, then people will do so. So, if you're in a situation where you're worried about pushing, where you see people avoiding pushing because it's scary, because they don't know what's going to happen, where you ever run builds and you don't know what they're going to do, try and focus on this kind of stuff. Accurately and thoroughly test your code to a point where you know what's going to happen, both from the build and the results of the build. Try and build quicker feedback loops, and keep it simpler so that people actually run it and it's easier to use. The third smell here. So, releases are very scary. Releases are where you get something useful done. If you're releasing rarely, and really this is a sliding scale, but I'd say probably less than once every couple of days, then there's a potential problem here. Releases are the point where you actually get something useful done. Up until that point, it's your code, it's useless to everybody else. Your customers don't care about code that's sat only in your servers. This is wasting time, right? If you've got a bunch of code that would be useful to your customers, that would make them money, that would get you more customers, that would make them happier, and you're just holding on to it, you're wasting potential value. And on top of that, you're not getting extra feedback you could usefully get from customers. If instead we release code sooner, this is very dark. If instead we release code sooner, then our customers get more value from it, but you get more value as well. You get useful feedback telling you more accurately what the next thing you should be doing is. You have more information about where you should be going next because your customers have up-to-date quick releases. You also have more information on problems. If you've built something that simply doesn't work, your customers will tell you very quickly. Even if you build things with high-level usability problems, you get more useful information once you've released that stuff. There is a huge compounding effect to releasing things and getting it out in the world, both for getting you more value, but also making you better at getting more value in the future. So we'd like to release if you look at large companies who are good at software engineering, you'll notice they do this pretty much in every case. Facebook, for example, release twice every day. This is one of the most high-profile websites in the world. If it goes down, it is international news, and they update the whole thing twice every day. Okay, GitHub updates hundreds of times a week. Again, big and high-profile. Again, releasing absolutely all the time. They talk about it a lot. There's some really interesting blog posts about the GitHub engineering team, and particularly about the extra speed and power it gives them. Doing lots and lots of small releases lets them quickly get stuff into users' hands, quickly see how it works, and quickly and effectively build software. And Netflix takes this even further and does hundreds every day. Netflix are huge, famous for their reliability and uptime, and they've got some great articles on this kind of stuff. And they are releasing things hundreds of times a day. So why isn't everybody else doing this? Okay, who here releases more than once a day? 2 hands. Okay, well done. Everybody else, why not? I think there's two main key reasons here. It's scary, you might break something, and potentially it's difficult. It takes effort and time to put stuff into the hands of your customers. So, the answers are fairly clear. Make it less risky. We would like really to have consistent environments, so we're testing in an environment that is exactly the same as what we're running in production at some point. If you can do this, you can give yourself a lot of confidence. If you're running in exactly the same environment, you're using the same data, so we set up in lots of projects automated builds that copy from production to staging, copy the data across every night, this kind of thing. So you've got up-to-date live data that you can test with. You can get very accurate tests that give you a lot of confidence that when you copy exactly the same thing to the identical servers with identical data, things are going to work. Automate everything. Perhaps this is fairly obvious, but it's absolutely key to driving this stuff. Manual steps, people do badly. Stuff breaks. People are very bad at doing boring, mindless, complicated tasks, and they will skip them and they'll get bored and they'll do them badly. And computers are really good at it. Give it to the computers. And measure everything. The key thing you see coming out of all of these companies doing this stuff is they talk about the metrics they track all the time. You can take this a really, really long way. Etsy actually has some really great talks about doing this in extreme depth. But even just tracking kind of the key metrics of your application and making that visible to your team gives you a lot more confidence and power here, takes away this risk. Having a graph on the wall that shows you the number of products purchased per hour gives you confidence after you've shipped something, if it's still there, that everything still kind of works. It's probably okay. And if that suddenly drops, you very quickly find out that you're really going wrong and you reduce the risk there. There's no chance you're going to put something out that is losing you loads of money and it's going to stay out for very long. Track these kind of key metrics, put them somewhere visible, have everybody familiar with them. And this allows you to worry less about releases, take away the risk and make it safer. And then make it easy. And again, the number one thing here is automating everything. People are very bad at doing things manually, and people are very lazy. If I have to go through and do 20 steps to release stuff, which again we see in projects coming in, I don't. It's nicer to wait until I've got a bunch more changes and then stick them all out together when it's easy later on. If it takes one click, the only thing that makes my decision on whether I'm going to release is whether I've got something to release and I want to get it out. I don't want my tools discouraging me from releasing. And if they put a big chunk of work in front of me, then that's what they're doing, and I'm not going to. So we really want to get this down to, yes, one click or fewer. If you can automate deployment right the way out, that's great. That's obviously quite scary, but most of the benefit comes down to getting down to that one click. If you've got a bunch of steps, probably they're most likely the kind of log into this server, run this command, log into this server, run this command, log into this server, run this command. Computers are great at that. You can make a very quick script that will run this for you and solve all of this problem quite nicely. And finally, get everybody deploying. Very easy to have teams where Bob is the one who does the deploys every week. If Bob is ill, nobody deploys. If Bob leaves, the business shuts down. You need to get the whole team invested in actually delivering this stuff, because this is where the team becomes useful, right? You don't want to have a team where nobody cares about releasing because it's Bob's problem, if releasing is the thing where you get something useful done. You want everybody to be invested in getting stuff out and released, and get everybody deploying. GitHub are a particularly good example of this. They get every single person who joined GitHub to release a new version of the site on their first day. You go through, I think you update the user page, you add your name and so on, and then you ship a full version of GitHub to the internet. Doing this stuff gets everybody invested, gets everybody understanding how deployment works, and builds a culture where you release all the time, everybody's used to it, everybody knows how it works, it feels safe, and you can quickly move. This is a great quote from Jez Humble. He's the author of a very good book on continuous delivery. This applies to a lot of this talk, but releasing particularly. It's really easy to get into a kind of negative spiral here. Releases are difficult, so I do them rarely. So the thing I'm releasing gets bigger and bigger and bigger. So it gets more difficult, more risky, so I do it even more rarely. So it gets bigger and bigger and bigger. And eventually you're releasing once every 6 months and you have a party if you didn't crash the business. If instead you push in the other direction and you try and release more frequently, smaller chunks, you quickly find the painful bits and you're in a better position to fix them because you're getting quicker feedback on how it goes. And you're more quickly delivering actual value to your users. If you push for frequency, you get ease out of it. If you turn this cycle around, you can make life better. So trying to move to deploying every commit really helps this. It's obviously very scary to do that into production. I wouldn't recommend diving straight into that. But one of the first things we do on projects that are struggling with deployment is set up development-only environments that are identical to production and deploy automatically into them with every commit, all the time. It's low risk, you're not going to break production by doing so, and you do have to value it so that you worry about it if you do break the development environment. But it allows you to quickly see what the problems are in releasing and lets you build that cycle where you do it a lot and you get better at it. It gets easier, and then you can start moving towards doing this in staging environments or even production if you're feeling keen. Nightly deploys also work quite well for this, both because what you're deploying at night should be a known good thing, and if that deploy fails, something is clearly quite wrong. But also because this solves the problem where you move around between different projects and deployment rots. It's relatively easy to have deployment steps for a specific project. Nobody's worked on it for 3 months. You come back to it, you can't deploy it anymore, and you put yourself back into this problem. And if you just have a night deployment, then as soon as, say, somebody changes the hardware, somebody updates Tomcat, whatever, and deployment doesn't work, you find that information out immediately. Nightly deployments are very easy to set up if you've already got automated deployment and give you a lot of value. So, if you're releasing things rarely, something is wrong. You're not adding value quickly. You are wasting money, or effort, or happiness, whatever. Instead, we're going to try and move to easier deployments, taking away the complexity, automating the hell out of everything, lower risk deployments, particularly measuring things, being aware of when anything goes wrong nice and early, so that we can make these more frequent. We can quickly put things into people's hands. The last smell then, not improving. Your build is never going to be perfect. In fact, does anybody here have nothing they could improve in their build processes? Good. Cool. So there's always something you want to improve. There are things you want to make better. Both because there's always something that's actually wrong, but also because your challenges change, right? The business is doing different things. You have different technical challenges coming up. We need to scale this now. We need to deploy to more servers. Our database isn't going to handle this. We need to add this new thing. Stuff gets more complicated and changes, and you have to be in a position where you can keep your build process moving to keep up with this. If you allow this kind of thing to happen, that's a picture of a burned out, broken building in the background. If you allow this kind of thing to happen, then it, again, escalates very quickly. You get into a situation where something is normal, things are broken, of course they're broken, we're not going to fix it. Another thing is broken, well, it was already broken, so we're not going to fix that. And it gets worse and worse and worse, and people add workarounds to deal with the thing, and then people add workarounds for workarounds. And you have to nip this stuff in the bud early, or it escalates and it gets very painful. So, again, a few big reasons why this happens. You lose momentum as a team. We haven't been changing this for ages, we're not going to start. It is hard to change your build processes, there's some effort involved, and it's not your problem. If you've just joined the team and everything's broken, it's not your responsibility to go and fix it. No momentum, I think, is the hardest one of these, because it's not really a technical problem at all. You're trying to motivate and persuade people that something is important, despite the fact nobody has been doing it for ages. I don't really have any magic answers for this, tragically. The best, most effective thing I've seen to make this work is simply trying to jumpstart it one area at a time. Pick a specific thing that you would like to make better. We would like to make deployments easy, and then go at that full force. If you make small improvements everywhere, you find things get slightly better, but they're still terrible and that's still normal and nobody cares. If you get something really good, it becomes very obvious if that starts to slip, and people get more invested in it being good. People will really like it if they can click a button and get a deployment straight out, and will actively work to keep that happening. If you make deployment only slightly easier, people won't really notice and won't really care. Focus on one thing at a time and really drive into making that really good, and then move on. One main thing, I'm not necessarily saying ignore testing here, but have a clear focus of the thing you are trying to do first. It can be hard to change your build processes. Particularly if you've got new people on the team. If somebody set it up and nobody else on the team knows how it works, it can be difficult to go in and fix issues even once you know they're there. Try and keep your builds simple, because that makes this much easier. If you're using build tools that are controlled and managed in the language that people use day to day, it's going to be easier for them to manage and make changes when they want to. If you're using something that's brimming with XML and nobody really understands Maven and so on, people are going to avoid changing it. People are going to say, oh, this doesn't really work, and I have no idea what to do about it. I'm not going to do anything. If instead you try and pick simpler tools, that becomes nicer. And similarly, trying to have your build process managed in code that's within the project that people can see and try and work out is easier to manage than having it in a series of text boxes on Jenkins. If you move that out into a nice, manageable, accessible place, people will change it more because it's easier for them to do so. Get everybody involved. Don't end up, again, with Bob doing all the build management. If you are Bob, don't do that. When people say people say they want something changed, pair with them, get them involved, show it how it works, get them to do it and guide them and make it easy to do that, and share this knowledge around the team. You want to get everybody understanding how the build tool works, preferably because it's very simple and easy to do, so that everybody can be trying to improve this stuff all the time. Finally, experiment explicitly. Experiments are very good. They are a great way of learning how to do new stuff better. Try this new tool, it's going to solve this problem we have. Does it solve it? I don't know. Have a conclusion to this experiment. Either it works, and you should commit to it, and actually put it into practice and get it done to a useful working state, or you should take it back out. You really, really don't want to end up with a build where you've implemented 40 different things in a tiny, fragile, broken state, because then nobody can change it anymore. If you want to run the system test, you have to use Docker, which we were using for 3 weeks. And if you want to go through to here, you have to use Vagrant. Then it runs with VirtualBox, and so on. You get lots and lots of little bits. People rewrite something in Haskell because it's cool and trendy and nobody understands Haskell. And you end up with this quite fragmented, broken environment. If Haskell's great, and everybody loves Haskell, sure, move everything to Haskell. Move whole chunks working, get whole suites of tests working rather than just having 1 or 2 proof of concepts. Put yourself in a place where your experiments actually work, or you pull them back out. Okay, last one. It's not my problem. So, how do you get people to actually take responsibility for this stuff? You want the whole team working together to make this stuff good. Retros, basically. Retro enthusiastically, and get people to be giving you the ideas for this. If you try and lay down diktats about we are going to fix such and such, nobody will care. If they come up with the idea of fixing such and such, they will love it and they will chase it to the end of the earth. Do retros, talk about what actual pain people are feeling, because this is useful information. This lets us find the problems in our system, and then all discuss together a plan for what you think you should fix. Try and focus that on a specific thing at a time, try and hone this down, and not go crazy, but talk to people, get everybody to agree on what they should do, and spread the work of doing so around the team. Get people invested in this kind of stuff by having them talk about it and pulling in their own ideas. And do this frequently. So I recommend weekly. If you're in real trouble, we've occasionally done bi-weekly ones when basically the whole project was we have to fix the huge mess and then we'll start doing some development. Chasing down and trying to make that better. Do this frequently and again, it becomes easier. If you start building a blame culture, this will all fall apart. It's very, very important in your retros that you do not end up with John released a terrible thing, or Bob. God, Bob. Instead, try and blame the system. By and large, you hopefully have developers that you trust that are trying to do the right thing. If something goes terribly wrong, they were trying to do the right thing, and the tools at some point made that more difficult for them. It has guided them in the wrong direction. Try and manage builds and improve builds so that you all working together to build a system that works for everybody, rather than blaming Bob for all your problems. Measure the actual success you get out of this. So it depends what you're focusing on, but there's lots of useful metrics you can quite easily pull out. Graphs of the number of deployments a day, for example, are very useful if you're trying to deploy more a day, or deployments a month. Chains work quite well. The number of days since we last had a spurious failure, this kind of thing. People will try and fight against spurious failure to make sure that when they add new tests, they're not randomly failing tests if they've got this number slowly ticking up on the wall, this kind of stuff. If you can make things visible, people think about it. It becomes an important thing just by having it on a screen on the wall. And stay focused. So we touched on this a moment ago, but really trying to have a specific idea of the things you're going to improve first, the most important, biggest problem you have, and how you're going to fix it. Makes it easier to get that done. Keep discussing this in retros, keep talking about what the biggest problem is, and try and remind the team. So we've, particularly if you've got kind of ongoing tasks that people need to remember all the time, remember to share your changes early, this kind of thing. If you say put reminders into Slack, that works quite well. So we set up a bot that just pinged at 9 o'clock in the morning in the Slack room and said, hey, could you share your code earlier? And it just keeps it in the front of people's minds, keep people thinking about the one thing that you're trying to do better as a team. If you can do this and avoid biting off too much, you can get the whole team behind, we are going to improve this thing, we are going to make it better. You can get it into a state where it's really good, and then people will care about it. People will make it better, and this starts to feed itself. So, you've got a team, you're not improving, everything's a bit of a mess. How do you improve? We build this as a team responsibility together. Get everybody behind you, bring in people with ideas, get everybody involved in working out what the most important thing to fix is, discuss it often, have retros weekly or more, keep talking about the issues you see and discuss them a lot, and focus on the specific problems that are biggest. Chase down the big bugbears, get them solved. So, wrapping up, it's important to note that a lot of these are cumulative. I've been mentioning again and again, these feed into each other, and there is a disproportionately powerful effect. If you start improving these, you'll quickly find that the improvements start improving the improvements, and everything gets better and better. And Twitter actually have some really great blog posts from their engineering effectiveness team, whose job is basically doing this 100% of the time. And they've got some really interesting analysis of the value they think they're getting out of this and the amount of time they think it is worth putting into this stuff. And it is much higher than you would expect, and they see much more improvement than you would expect. It is far more likely you are undervaluing improvements to your system than you are overvaluing them. And again, this is gardening. We're not chasing ivory towers. We're not chasing some beautiful, glorious thing written in Haskell that they will talk about for generations. We are focusing on clear problems, on pruning things, finding out what the actual pain is, the actual smells you're seeing in your build, focusing on finding clear, concrete improvements that will make them better. So that is the lot. Again, I am Tim Perry, Pim Terry on Twitter, and I will stick the slides out in a minute. And I do work for Software, and we are enthusiastically hiring. Thank you very much.